All right, we're going to be solving quadratic equations this time by using the quadratic formula. It's another way to solve equations that are quadratics. It's actually our fifth way we've talked about this year. The benefits of using the quadratic formula, well, it can be used to solve any quadratic equation, and it will give exact solutions. Those are some of our benefits. So let's just jump into it, what a quadratic formula is. So when, let's assume we have, when our quadratic is in the form ax squared plus bx plus c equals 0. When that's true, then we can use the quadratic formula to find x. Okay, so x is equal to the opposite of b, or negative b, plus minus the square root of b squared minus 4ac all over 2a. That is the quadratic formula. Okay. Some things to note here. It's the negative b is read as opposite of b. Okay, so if b is positive, this is b. When you put it in the quadratic formula, it will be negative. If b originally is negative, when you put it in the quadratic formula, it will be positive. Okay, and then you have this piece under here, and this is 4 times a times c. Okay, so what we're going to do is we're going to try some problems out using that. Okay, solve each equation using the quadratic formula. So remember, first you have to put it in the form of ax squared plus bx plus c equals 0. Okay, so I'm going to start by doing that in this first one here. 3x squared equals 6x minus 3. And I always like to keep a positive. However, it doesn't really matter if you could have moved the 3x over. I'm going to move the 6 and the negative 3 over. The way I'm going to do that is I'm going to, if you think of your equation here, I'm going to subtract 6x from both sides, and I'm going to add 3 to both sides. Okay, so really what happens is I end up with 3x squared minus 6x plus 3, and that equals 0. That zeroes out these here. Okay, so there's my equation. Okay, now I'm going to need quite a bit of room, so I'm not going to leave all that there. I'm actually just going to rewrite it as 3x squared minus 6x plus 3 equals 0. It's really important that you stay organized when you do these. And I'm also going to identify what a, b, and c are here. All right. And so I'll always do that today here. A is equal to 3. It's the number in front of x squared. It's coefficient of x squared. B is equal to negative 6. It's the number in front of the x. And c is your constant there, 3. Okay. And so from this point, we just use our quadratic formula. X is equal to the opposite of b plus minus square root of b squared minus 4 times a times c all over 2a. Now you know I didn't put any numbers or letters in there. I'm just writing it with parentheses. Okay, and we know this formula. When you're working on this, you may want to just rewrite it at the top of your page. Okay, but when I'm substituting values in for a, b, and c, I need to use parentheses. So a is 3, b is negative 6, c is 3. Okay, so the opposite of b, well, b is negative 6, so I'm going to write negative 6 in that parenthesis. Plus minus b squared, so negative 6 squared. Minus 4 times a, which is 3, times c, which is also 3. All over 2a, which is 3. Okay? And so now I can do the math here. Right? So we'll go on to that. We've got the negative 6, or the opposite of negative 6 is positive 6, plus minus square root of negative 6 squared. Well, negative 6 squared is positive 36. And when you square something, whether it's negative or positive, it's going to be positive. So whatever you get right here is always going to be positive, that part of it. And then minus, it's really important that you pay close attention to this piece. Okay. In fact, as I'm doing these, I generally like to circle that piece and just say, well, that whole piece, negative 4 times 3 times 3, that ends up giving me 36. Well, negative 36, right? And so when I put that in here, I'll get rid of that there. That's a negative 36. So 36, negative 36, or minus 36, all over 2 times 3, which is 6. Well, no, when I finish this problem here, I get 6 plus minus the square root of 0 over 6. Well, remember when in previous lessons, whenever you get a square root of 0, that told you something about the solutions here. In this case, what I know is whenever there's a square root of 0, that's going to tell me there is one solution, one real solution there. Okay, so let's just kind of keep that in the back of our mind for later. All right. So if we continue to simplify from here, that's going to give us 6, and the plus minus piece is gone. That's why, because this part right here just becomes 0. So we just have 6 over 6. That's how we get down from having two solutions with the plus minus to only one. 6 over 6 is 1. So in this case, x equals 1. It only equals 1. There's only one real solution. It doesn't have to be, when I say one real solution, it doesn't have to be the number 1. It could be 19, but it's one real solution there. All right. You can always plug it back in to test it, right? 3 times 1 squared is 3, so this side would be 3 when you put your 1 in. And 6 times 1 is 6, minus 3 is 3, and 3 equals 3, so we're good. All right. Well, we're going to go ahead and do another one here. Write it in ax squared plus bx plus c form. All right, we need to write it in this format right here. I guess I had that at the top of the other page here. Okay, so I'm going to keep my x squared there. I'm going to add 3x over, and I'm going to subtract 40 over. I'm going to identify a, b, and c again. In this case, a is equal to 1, b is equal to 3, and c is equal to negative 40. Okay, and then we'll go ahead and go through the process here. X is equal to the opposite of b plus minus square root of b squared minus 4 times a times c all over 2 times a. Okay, so once again, as I'm doing that, I just put parentheses where the values are. So looking at this, I have opposite of b, well, b is 3, so substituting those pieces in there, I get 3 plus minus 3 squared, 4 times a, which is 1, times c, which is negative 40. You may not want to squish yourself up like I did there. I used the wrong color there, but that's okay. And then all over 2 times a. All right. Well, cranking through the math there, we end up with negative 3 plus minus square root of 9 minus, I should stop doing the minus there, right? Okay. That's negative 4 times 1 times negative 40. Negative 4 times negative 40, that's a positive 160 times 1. That gives me positive 160 right there. And so what that means is I'm going to put plus 160 in here. That's all over 2. Well, negative 3 plus minus the root of 169 over 2. Well, at this point, I'm going to pause for a minute, and I just want to draw your attention to my root. That is a positive square root. Okay? And remember, whenever you had a positive square root in the past, whenever our root was positive, we ended up with 2 solutions. Okay? And once again, I want to kind of bring attention to that. Okay? And so the reason that happens, remember, as we're looking at this, this is negative 3 plus root 169, which is 13. Okay? But we also have that minus, also plus minus. So we're going to have 2 problems there in a minute, all over 2. Okay, so really it means I have negative 3 plus 13 over 2 and negative 3 minus 13 over 2, which is, well, 10 over 2, or 5, and negative 16 over 2, or negative 8. Okay, so my solutions, x equals negative 8 and 5. They're my 2 solutions. And we knew there were going to be 2 because the root up here was positive versus here when the root was 0. Okay. Let's try one more here. All right. I'm going to go ahead and bring that 5 over to begin with. So I'm going to have 8x squared plus 6x plus 5 equals 0. And once again, A, in this case, is 8, B is 6, and C is 5. And so if we go through the math, x equals, now I'm going to stop using the parentheses as much. I'm going to just say the opposite of b, so negative 6, because b is positive, plus minus the square root of b squared, which is 36, because 6 times 6, minus 4 times 8 times 5. Now notice, when I'm kind of doing those other pieces in my head, that's the one piece I don't do in my head. All over 2 times a, or 2 times 8, which is 16. Okay, so this piece I still kind of leave separate. That's a place where a lot of mistakes are made. So I have a negative times a positive times a positive, right? So I have positive or negative 160 from that chunk right there. So I end up with negative 6 plus minus the square root of 36 minus 160 over 16. And some of you can see right away that when I simplify inside that radical, 36 minus 160 is negative 124. Okay? Now please keep in mind, whenever you get a negative inside your radical, right here, recall a negative inside your radical. Oops, let's get a pen here. All right, let's see if I can actually get the correct color here. A negative inside my radical means there are no solutions. Right? That's undefined. And so when we see that, we get an undefined, that means we can automatically stop working on the problem. You may just double check your work and say there are no solutions, or no real solutions in this case. And that's the only type of solutions we're dealing with in algebra, are the real solutions. But when you get to algebra 2, there will be imaginary complex solutions there. Okay? All right, so three different scenarios. Now, it'd be nice, rather than having to go through all this work before we figure out if there's no real solution, to actually be able to calculate that. And what I want to do in order for us to see that is I want to focus in on the chunk that's inside our square root there. The 0, the positive, and the negative. Okay? So that thing inside the square root is b squared minus 4ac. And that's our next piece here. b squared minus 4ac, that is called your discriminant. The thing inside the radical. Okay, so if I was writing out the quadratic formula, x is equal to the opposite of b plus or minus the square root of, well, this piece right here, b squared minus 4ac. Okay, all over 2a. All right, so this chunk right in here, the stuff in red, that is our discriminant. Okay, the discriminant helps us to figure out how many solutions there are. Just like we did on that previous page, when our discriminant, when b squared minus 4, and actually let's try to, I'm going to try to stay color coded for us here. Okay, when b squared minus 4ac was, our last problem was negative, equal to a negative number. Which, by the way, what that really means, another way of saying that, in fact, most textbooks will say it this way. When b squared minus 4ac is less than 0, okay, really that's what that means, right? Okay, then we have no real solutions. No real solutions when that happens, okay? And so, thinking about your graph of that, if I have an xy axis, my graph of something with no real solutions, oops, is something that a parabola that doesn't cross the x-axis. Remember, our x-axis here, those are our solutions where it intersects. Well, no real solution. It doesn't cross it. Okay? Let's try another one here. If b squared minus 4ac, when that is equal to 0, okay, that means I have that would mean I'd have one solution. It would go down and hit the graph, or the x-axis, and come back up. Okay? That means I have one real solution. So using that discriminant helps us determine how many solutions there are. And then the last one, okay, if we have b squared minus 4ac equal to a positive number. In other words, another way of saying that, and like I said, most textbooks will do it this way with an inequality, it's greater than 0. That's another way of saying that. Well, there's our xy. When it's greater than 0, and that means we have two real solutions, and it crosses the x-axis in two locations. Okay? Now that's pictorially, but we did that algebraically on the previous slide, right? We had that b squared minus 4ac equal to 0. b squared minus 4ac was positive. b squared minus 4ac was negative. We had one solution when it was 0, two solutions when it was positive, no solutions when it was negative. Okay? Pictorially, that's what's happening. Okay, so let's go ahead and use that discriminant to actually look at some problems and figure out how many real solutions there are. So find the value of the discriminant, then state how many real solutions. You know what, I forgot to add one thing here, and I kind of, it was kind of assumed, but one note you might want to make on this previous slide, you still have to be in ax squared plus bx plus c equaling 0. Okay? So when you have it in standard form, all right, that's your discriminant. So the reason why I put that is because our first one here, notice it's not in standard form. I had to move that 10 over. So we get 9x squared minus 3x, and I add 10 to both sides, so that gives me plus 2. Notice how easy this is from here. I mean, just identify A, B, and C real quick. A is 9, B is negative 3, C is 2. And you do b squared minus 4ac to find the value of the discriminant. Well, that's negative 3 squared minus 4 times 9 times 2. Substituting those values in there. Okay? And so we now have 9 minus, well, 4 times 9 times 2, that's 72. And 9 minus 72 is negative 63. This right here is the discriminant. That's the value of it there. It's our first solution. Okay, how many real solutions are there? Well, since our discriminant's negative, there are no real solutions. Okay, and remember why that is. Because when I say the discriminant's negative 30 or 63, that means if I were to be doing the quadratic formula, that b squared minus 4ac is this thing right here. That means that negative 3 would end up in here. That's what we just figured out. And you can't have the root of a negative, so there's no real solutions. Okay? All right. Well, let's try another one here. So getting it in standard form, I'm going to add that 6 over. So negative 2x squared minus 8x. And we add 6, we get we get minus 8 equals 0. Now, if you're in my class this year, when we did this in class, we actually had a positive 2 here. I meant to have a negative, so I fixed that. But if I gave you a note page from 2018 here, then that would be you'd have to make that a negative. Okay? So I'm going to go ahead and put in A, B, and C here. A is Well, unbelievable there. Let's fix that up. A is negative 2, B is negative 8, and C is negative 8. Okay? Well, B squared minus 4AC. Okay, well, B squared, that's negative 8 squared minus 4 times negative 2 times negative 8. Well, negative 8 squared is positive 64. Anytime you square a negative, you get a positive. And then negative 4, negative 2, and negative 8, negative times negative is a negative. 4 times 2 times 8 is 64. Well, 64 minus 64 is 0. That is the value of the discriminant. Which means, remember what that means. It means up here in the quadratic formula, we would end up having the square root of 0, which would wipe out this back portion of the quadratic formula. We just have negative b over 2a. Okay? So that means there's only one real solution. Let's try one more. All right, putting it in standard form. I have to subtract 8x over. All right, you know what? I got a mistake on here again. This should not be an x. I am sorry. I'll fix that. So let's subtract 8 over here. So we have negative 7x squared plus 16x and minus 8 equals 0. Okay? And so what happens here is our a, negative 7, our b, 16, and our c, negative 8. Okay? So if we do opposite of b plus, or excuse me, not opposite of b, b squared minus 4ac, we get b squared is 16 squared minus 4 times a, which is negative 7, times c, which is negative 8. Well, that's 16 times 16, or 256. And negative 4 times negative 7 times negative 8, well, that's negative 224, which ends up giving me a value of 32. Which means, since that's positive, that 32 would end up in here. And we'd have to do whatever b is plus minus the root of 32. So plus root 32 minus root 32, there will be 2 real solutions because we have that plus minus. So there it is. So the discriminant helps us determine how many real solutions there are. All right. Well, we've kind of been building up to this point now. All right. So choosing the best method when solving a quadratic equation. So it's really, in our textbook, really we've covered 5 methods. We've factoring in 7.5 through 7.8, graphing in section 9.2, square roots 9.3, completing square 9.4, and now quadratic formula. And there are advantages, okay, to doing them this way when solving quadratic. So some advantages of factoring: it's quick if you can factor it. It's a quick method. Okay, so it's quick if you can factor. Well, maybe you should say not if you can factor. That implies you might not be able to actually do factoring. So maybe it's quick if the equation is factorable. Okay? So if it's able to be factored. Okay? Disadvantage? Well, kind of on that same line. Some equations cannot be factored. Okay, so it doesn't work for everyone. Some equations can't be factored. All right. Well, graphing. Graphing's another method. Some benefits there. I have 2 I can think of. Well, you can easily see the solutions. Right? They're just the x-intercepts. Okay, so you may even make a note of that. Another benefit I can see, you can use a graphing calculator or Desmos. Which usually makes it fairly easy as well. Disadvantages? Well, it's nice if you have exact x-intercepts, but sometimes the solutions are not always exact. Sorry, my pen is having issues here. It's probably the user error. Okay, they're not exact, which means you may have to round or estimate, and that's never a good thing. Square roots. Square roots was another, and remember, just when we're dealing with square roots, we're talking ax squared. It has to be in this format, plus, not plus b. We don't have a b term. Plus c equals 0. So b is gone, right? So it's easy. We can use it quickly if we're in this format. Okay. The downfall, well, you cannot use if there is a b, well, I'll just say if there is bx in there. Okay, so if there's a b term. Our last lesson, previous one, was completing the square. And completing the square, a lot of people like it. It can be used quick if a is 1 and b is even. All right, which also lends itself to the difficulties there, the disadvantage. It can be difficult. It's not impossible, but it can be difficult. The process is difficult if a is not 1 or if b is odd. Remember, that's the process where you had to take half of b, right? So if you want an example over here, I can give you a quick one, like x squared plus 4x plus or equals 7, right? Where we took half of our b term to become x plus 2. Let's change this not to 4. Let's make this 6. That way we don't get double 2's there. So x plus 3, and then we square that and add it to the end. So it'd be plus 9. And we'd have to add that 9 over there. So that would equal 16. And then we take the square root of both sides, right? So we get x plus 3 is equal to plus minus the square root of 16, or plus minus 4. So x would equal negative 3 plus 4 and negative 3 minus 4. Right, we'd subtract that 3 over. Okay, so it equals those two things. Or you could say it equal 1 and negative 7. Okay, it's just a quick review on that. Now, that's a nice process. Some students really don't like it. Some really love it. But it works well if you can cut the b term in half. Okay, and so the last one here, so I'll pick a different color here, the quadratic formula. The benefit there is what I said at the very beginning. Can always be used. So if you want to memorize 1 for your test, this is the 1. Okay, that's 1, and it gives exact solutions. You don't have to round them. Now, you might have to round if they ask you to at the end, or if you get a square root that's not perfect. Okay. Downfall, I guess, is it's a long process with multiple calculations. And when you have multiple calculations, it's easy to make mistakes. Many places to make mistakes. But if you take and be precise in your use, then it's not too bad. Okay. So here's what you get to do. You get 3 problems, and you get to choose which method you want. Now, I have my personal favorite, and I'll tell you, my personal favorite is factoring. So the first thing I always do, I actually look and say, is there a B term? And if there's a B term, I automatically try to factor. If factoring doesn't work, I'll go to completing the square if B is even, and if it doesn't work, I end up with quadratic formula. That's the order I go. I rarely do graphing unless I need to see pictures. Okay, so when I look at, say, this first problem, I go, well, there's a B term, and that means I can't use square roots. No matter what form I use, with the exception of, I guess, completing the square, I've got to have it equal to 0, but since B is odd, I'm going to set it equal to 0 because I'm going to try to factor it first. That's generally what I would do. Now, if you're not good at factoring, 2 notes. A, you better get better at it. You better work on that before you get to Algebra 2. And B, well, then maybe you don't try factoring. Maybe you go to Quadratic Formula. I'm going to try factoring. So a quick reminder on factoring. I use this method, that X there. Okay. 2 things that multiply to make 4 times 5, A times C, which is 20. I got that 20 by multiplying first term by last term, or first coefficient by last coefficient there, 20, and add to the middle, 9. Well, I recognize that 4 times 5 actually add to 20, or multiply into 20, and add to 9. Okay. Well, the next thing I have to do is I have to divide by my A term. So I'm going to divide by 4. Okay, well, 4 fourths is 1, and 5 fourths I can't reduce. Okay, now I'm going to actually show you how it sets up into your quantities. You have your x plus 1 then. Just bring that 1. And you have your, well, this 4 goes out in front, 4x plus 5. The denominator goes out in front, equals 0. And now you factored it. And your solutions, well, that means x plus 1 equals 0 when x equals negative 1. Okay, and here, 4x plus 5 equals 0 when, well, we have 4x, we have to subtract 5, and then we have to divide by 4. All right, so when x is negative 5 fourths. Now these 2 numbers, negative 1 or 1 and 5 fourths, should look familiar. They were right here. So really your solutions are sitting right here. You just take the opposite, negative 1 and negative 5 fourths. Before, you don't have to put it in that form if it doesn't say to factor. You could stop right there and say, well, my answer is the opposite of this. It's negative 1 and the opposite of this, which is negative 5 fourths. Okay? You could have used the quadratic formula. You could also use completing the square. Both would have taken longer. Okay? So let's take a look at this next one. I look at it and I go, well, first there's a B term, so I'm not using square roots. I'm not using graphing. Okay, I'm going to try completing the square because B is even and A is 1. So I'm going to give myself a little room here. Let's say I'm going to have to add something to both sides to complete that square. So we got to complete this perfect square. Okay, well, take half of 12 and it drops in there. It gives me half of negative 12, which is negative 6. X drops down. We square that negative 6 and that goes in right here. You remember completing the square, so that's positive 36. And whatever I do here, I have to do over here. So I have to also add 36 there. So 2 plus 36 is 38. So I get x minus 2, quantity squared, equals or not x minus 2 quantity squared, x minus 6 quantity squared equals 38. Take the square root of both sides. I get x minus 6 is equal to, whenever you put the square root in, you've got to put plus minus in front. And it's a positive, so I'm going to have two answers. I'm going to add that 6 over. X is equal to 6 plus minus root 38. Well, that's the exact answer. Now, if we wanted to round this, okay, this would be a fine answer as well. Unless for some reason they actually said, well, go ahead and round your answer. If they said round your answer, you'd have to do 6 plus root 38, which happens to be 12.16 if we round to the nearest hundredth. And then 6 minus root 38, which happens to be negative 0.16. Okay, so these are also your solutions rounded. Okay, just put them into your calculator and calculate them out. It just depends if it asks. And by the way, that's how you could report answers from the quadratic formula as well. The quadratic formula, at the end of it, you would end up with this. Okay, all right. Well, and then I approach my last one here. Okay, and kind of going through my process again. A, B, C, there's a B term, so I can't use square roots. I'm not going to use graphing. I'm going to try factoring, see if it works. Are there two things that multiply to make 2 times negative 5 or negative 10, and add to make negative 3? So can two things multiply to make that, and add to make that? Well, I could test. 1 times 10 doesn't work. 2 times 5. Well, 2 and 5. Negative 5 and positive 2 work. That gives me negative 10 and negative 3. All right. And then we're going to go ahead and divide. Remember, divide by this by A. So A term is 2, so we got to divide by that 2. That gives me 1. And this one just stays as negative 5 halves. So if you remember what I said over here, your answers are just sitting right there. Okay, so one answer is going to be x equals the opposite of negative 5 halves, which is 5 halves. And the other answer is x equals the opposite of 1, which is negative 1. Those are my two answers. Now, why did I give myself so much room? Well, because just to prove to you I'm not joking about that, this piece jumps in, it goes 2x minus 5. And this piece jumps in, x minus 1, or x plus 1. And this part would have to get set equal to 0. 2x minus 5 equals 0. We'd add 5, so we get 2x equals 5. And then divide by 2, x equals 5 halves. Right there. And then we'd set this part equals 0. X plus 1 equals 0. Well, x would equal negative 1. Yeah, that's right there. And you could try it with quadratic formula to work as well. And if you really want to do completing square or graphing, it would work that way as well. So all 5 of those would give you the same answers. Just sometimes there's faster ways. All right. Well, that's all I got for you. Good luck.